mathsy.com. This is your Joycey ma'am. Today we are going to see the chapter triangles. Under that, basic proportionality theorem or Thales theorem. We have seen the introduction in our previous video. So the continuation of the chapter triangle we see in this video. Are you all ready? Shall we start? Here we go. Basic proportionality theorem or Thales theorem. We have learned what are the conditions for the triangles to be similar. So if the corresponding angles are equal, then the corresponding sides are in equal ratio or same ratio. Then we say that those two triangles are similar. Now we extend our study for the particularly the triangle about the same ratio. So the Thales was the mathematician, and he said the following concepts. And to prove that following concepts, and he proved the theorem. So because of this theorem, what I say about the similarity of the triangles holds true. So he proved in this way by giving us the theorem. Before that, children, I would want you to recollect a few concepts. The concepts are, there are 4 concepts. I would like you to recollect the concept when I'm teaching you those concepts what we have studied in our earlier classes itself. So, equiangular, you must have heard the term equilateral triangle. That means all the sides are of equal in length. Then we say that it is equilateral triangle. The property of an equilateral triangle, the angles are also equal. Each angle is equal to 60 degree. Then it is said to be an equilateral triangle. So I have a triangle. This angle is 60 degree. This angle is 60 degree and this is 60 degree and all sides are equal. This is said to be equilateral triangle, and you can say that this is equiangular also. That is, all the angles are equal. This is the first concept. Now this Thales, what he said is the corresponding ratios, sides, the corresponding sides will be in equal ratio for the equiangular triangles. So the corresponding sides will be in same ratio for the equiangular triangles. So this is what he is going to prove by giving us the theorem. I told you the angles are equal for the square and the rectangle. In our previous video, we learned in square and the rectangles, the angles are equal 90 degree, but they are not in same ratio. The sides are not in same proportion. That means, ma'am, you said yesterday like this, now you are telling equiangular triangle, that means the corresponding sides will be in same ratio. How this could be possible? Yes, yesterday, that is in previous video, I said about the quadrilateral. Now I specifically telling about the triangle. This is not my viewpoint, this is the viewpoint of Thales, the mathematician Thales. He said in a triangle, this holds only for the triangle, not for any other polygon. In a triangle, if the triangles are equiangular, so I have taken this equilateral triangle, but it is not the concern only about equilateral triangle. I can take the another triangle. Suppose the triangles are A, B, C, and my another triangle is P, Q, R. Now I say that angle A is equal to, it is an acute angle, so let me have it is 80 degree. So this is also 80 degree, and this is 70 degree. So this is also 70 degree. So this is 30 degree. So now you can say that these are the corresponding angle. Angle A corresponds to angle P. Angle B corresponds to angle Q, and angle C corresponds to angle R. So it is not necessary that the triangle must be an equilateral triangle. It can be any triangle, but it must be equiangular. Hope you understand this concept. So I have this triangles with equiangular, with equiangles, the corresponding angles are equal. Then Thales says that the sides will be in same ratio. The corresponding sides will be in same ratio. Means what? How do you write it? AB by, this corresponds to this one, and this corresponds to this one, and this one corresponds to this one. So AB by PQ is equal to BC by QR is equal to AC by PR. This is what he says, that in an equiangular triangles, the corresponding sides will be in same ratio. That's what we are going to prove by this theorem, that is which is called Thales theorem or basic proportionality theorem. So this is one of the important questions in the board exam. So you can expect this theorem in your board paper also. Why? Because it's an important question. So the question comes like this, that is, state and prove Thales theorem and its converse. You have the converse also, and I explained in the previous video what does it mean by converse. And basic proportionality theorem, so state and prove basic proportionality theorem. The proof is the same for both the theorems. Otherwise, they give you the statement, they write the statement, and they will tell you to prove this theorem, this following theorem, and they will give this statement. So these are the three ways that they can ask you this question. So it will come for 5 marks if they are asking for board paper. Mostly it used to come for the 5 marks with its converse. Sometimes without converse also it can come in 5 marks. Sometimes it may come in only 3 marks. So either it can be only the Thales theorem or it can be only the converse of the, either one of this will be asked for 3-mark question. So hope you understand what is equiangular and what we are going to prove in this theorem. Children, before proving that theorem, before giving that statement of the theorem, I'll give the statement of the theorem. Before that, I want you to remember this concept also. Hope everyone knows the area of a triangle. Area of a triangle is nothing but half base into height. Of course, it is for 90-degree triangle, it is half base into height. Otherwise, if the base and the heights are not given and the sides are given, that is, it's a scalene triangle. Any other triangle other than 90 degree, even for 90 degree, if the height is not given, only 3 sides are given, you can go for it. But it is easier to use your Pythagorean property. That would be better way than going for Heron's formula. So you have 2 formulae for finding the area of a triangle. That is, one is a 90-degree triangle, which is equal to area is equal to half base into height. Another way of finding the area of a triangle, if it is a scalene triangle and you are given ABC, not the height. Here this is the height, this is the base. What do you mean by the height? Nothing but the altitude. That is a perpendicular line drawn from the opposite vertex to the base. That is nothing but a height, or we call it as altitude. Now here that height is not given. So how do we find the area? There comes this head-ons using that formula, that is A, B, C are given. 3 sides measurements are given. Then you will go with S is equal to A plus B plus C divided by 2, and the area is equal to square root of S into S minus A into S minus B into S minus C. What is S here? S is the semi-perimeter. So 2S is the perimeter, S is the semi-perimeter. Hope you know all this. Now, my concept is not about area. My concept is about your the altitude of a triangle. Children, I told you that is, this is the base and this is the height. Now, my triangle is in this shape. Okay, so ABC is my triangle. Now BC is my base. So I have my height. That is, suppose AP is my height. Okay, BC is my base and AP is my height. Okay, now I want AB as the base, and from where you will get your height? Height will be always from the opposite vertex. So AB is a base, means the opposite vertex is C. So when I draw the height, it is a condition for the altitude, it must make 90 degree. So when I draw here, it is not possible to draw 90 degree here. What I do, I just extend my base and I get my 90 degree here. So you can see here, since the base is AB, but the height is, suppose CQ is my altitude for this base AB of this triangle ABC. Hope you understand. It is not compulsory that the altitude must lie within the triangle. The altitude can lie outside the triangle. It can be taken into consideration. Even though the base is only this much, you will extend that base and you will draw a perpendicular line. Why? Because altitude perpendicular is must. So it must make 90 degree with the base. That is very, very important thing. So hope you understand. Now the base area of this triangle is equal to, I know half base into height, half, which is the base. Base is AB into my height is CQ. Hope you get my point. What am I trying to teach you here? So half base into height is half AB into CQ. Of course, you must have been given the values for the sides and the height. You will go and substitute. If not, another way of, you must find the way to find the value for CQ or AB. Some hint will be there in that question, and then you will go and substitute to get the height of this triangle. This is the main concept, first main concept to understand before proving this theorem. Okay, this is one concept. And the second concept is, this was the concept which was there before Corona, but now in rationalized chapter, this chapter itself is deleted, that is area of parallelogram. Now, I tell you the quadrilateral, that is, I have my quadrilateral. Okay, so in this quadrilateral, I can make ABCD is my quadrilateral. So I can draw the diagonal and I can divide this quadrilateral into two triangles. That is, one triangle is triangle ABD and another triangle is triangle ABC. Now, you know that this quadrilateral is nothing but a trapezium. That means AB is parallel to C. AB is parallel to CD. Now, you can see here triangle ABD and triangle ABC lie on same base AB and between the same parallel AB and CD. This statement to grasp the statement, it will take little time. Why? Because it is new for you. But this was the 9th standard chapter. Now it is deleted. You can see here, I told you, these two are the parallel lines. And you can see here the triangles. Two triangles are triangle ABD is one triangle, and another triangle is triangle ABC is my another triangle. So they lie on the same base. See, they lie on the same base, but between the same parallel. They are not extended like this. It is going one is no. It is between the same parallel they are. Then what we can say? The area of triangle ABD is equal to area of triangle ABC. This is the second concept you must know. That is, area of triangle ABD is equal to area of triangle ABC when they lie on the same base between the same parallel. Hope everyone understood these two concepts. These two are the concept what we are going to use it in this theorem to get our proof. So on the way of proving the theorem, if I explain this, you get confused. Theorem is going in one way, and I bring the two statements which you are not much aware of it, then you get confused of the proof as well as with this new concept. So that's why I wanted you to understand beforehand before going for the theorem. So these two are the concept that we are going to use. That is, the area of a triangle, base is given, the altitude can lie outside the triangle. How? When we extend it, we can draw the altitude. And here the two triangles lie on the same base between the same parallel, then the areas of those two triangles are equal. So these are the two concepts. So hope everyone understood up to this. Now we directly go for the theorem. The theorem says like this. That is Thales theorem. The theorem is theorem 6.1. So theorem 6.1, it says like this. I have a triangle. So let me name the triangle ABC. Okay, we are talking only about the triangle at the moment. At the moment we are similar figures and all. We finish and we have come to study only about the triangles. That's why this chapter is named also triangle. So I have a triangle ABC, and I'm drawing a line. That is, from one point, it need not to be the midpoint. From one point, I'm drawing a line. How I draw the line? I draw the line such that it must be parallel to this side. So I draw the line such that it is parallel to this base BC. Then this line will intersect the other two sides in two distinct points. That is, I name this side as 1 and this 2 and this is 3. So this is the first side of a triangle, this is the second side of a triangle, this is the third side of a triangle. Now I draw a line from one point from first side of a triangle such that it must be parallel. I am not drawing the triangle like this and all. Why? Because see, it is not a parallel. I have to draw such that it must be parallel to the third side, and it will go and intersect the second side at a distinct point. Then what Thales is telling us, this two sides will be divided in same ratio. That is the mathematician Thales is telling, that is these two sides are divided into same ratio. I name this is D and E. Now I say the statement of a theorem. A line is drawn from one side of a triangle parallel to the other side will intersect the third side. So this will be second side you can have, and this is third side. So it will intersect the third side at two distinct points. Then those two sides are divided in the same ratio. Hope you understand. What do you mean by the ratio? Ratio is nothing but AD by BD is equal to AE by C. That's the meaning of it. So, a line is drawn from one point of the one side of a triangle parallel to the other side, and such that it will intersect two sides at two distinct points. Then those two sides will be divided in the same ratio. Hope you understand the statement of this theorem. This is called Thales theorem. So I am given DE is parallel to BC. Then I have to prove AD by BD is equal to AE by C. So this is in our previous classes, especially in circles chapter itself, I told you how to give the proof for the geometry chapter. So you must give the proof for the geometry chapter according to the steps. I told you, I described there are 5 steps. So you can go and see in circles chapter how I explained the proof, how to give the proof for the geometry chapter. So the same way, this is also one of the geometry chapters. So I have to write in such a way that in steps. So what are the steps? It will go, first step is what is given. So what is given in the step, that is what I have to write. So children, I read once more the statement. If a line is drawn parallel to one side of a triangle to intersect the other two sides in two distinct points, then the other two sides are divided in same ratio. So if a line is drawn parallel to one side of a triangle, divide the intersect the other two sides in two distinct points, then the other two sides are divided in the same ratio. Now I have to prove this one. So what is given? First point, ABC is a triangle. And second point, DE is parallel to BC. Hope everyone get it. And third point, there is no third point. This is what it is given. And then to prove, what to be proved? I have to prove it is in same ratio, AE by C. This is what I have to prove. Okay, so how am I going to prove this theorem is, I'm going to have the construction. I told you after proof I'm going to have the construction. Mostly in the geometry chapter this point is important. Without this construction, some theorems or few questions you cannot prove. So you have to construct. Now I'm going to construct how? Using the area of a triangle I'm going to prove this. So I told you area of a triangle means there must be a height, altitude. So the altitude I draw like this and I draw like this. For which one? AD the altitude and AE the altitude. So I name this as M and N. Okay, and then I'm going to join this also and this also. So these are the construction. So 4 dotted lines I put it. So how do you put it? You put it like this, need not to be the midpoint joining, and then you will join. Now you have to be very careful when writing the area of a triangle. That is, area of a triangle is equal to. Now, which area you are taking? Here, let me write DM is perpendicular to AE. Why? Because then only it becomes altitude. And then EN is perpendicular to AD. Correct? So construction is DM perpendicular to AE and EN perpendicular to AD. Now I am going for the proof. So I rub this one. I go for the proof now. How am I writing the proof? So proof we go. So consider the triangle ADE. Consider triangle ADE. The first point, area of triangle ADE is equal to, I know half base into height, which is equal to half into, if you have taken AD as the base, then your perpendicular is EN. Hope you understand. AD as the base, your perpendicular is EN. And you can write the another way also. Area of triangle ADE is equal to, if you have taken AE as a base, DM is an altitude. So half into AE into DM is the altitude. Hope everyone understand this first 2 points. I name this is 1 and this is equation 2. Okay. Now my third point is, I take the triangle. My triangle is BDE. I take my triangle, area of triangle BDE. Now the concept what I told you, what I explained you before. If BD is the base and EN is the altitude, see it lies outside. It is extended and it lies outside. So I can have half BD into EN. And the similar way, I can have my fourth triangle, that is area of BDE I have taken. Now I am taking CED. Hope everyone get the triangle CED. So triangle CED is again half into, that is CE is the base, DM is the altitude. So CE is the base and DM is the altitude. I name this 3 and 4. Hope everyone understood how to take the triangle's area. Now got it. Now ma'am, why you are taking different triangles, ma'am? My aim is to prove AD by BD. So I must have this AD I must have and BD I must have. That's why I've taken those 2 triangles. The similar way AE I should have and EC I should have. So that's why I've taken those 2 triangles. So as simple as that. Now what am I going to do is, 1 I am dividing by 3 and 2 I am dividing by 4. That is, this is area of triangle ADE. Now I am going to divide the triangle in this 1 divided by 2. So what is going to happen? That is 1 divided by 2. So not 2, it is 3. That is area of triangle ADE divided by area of triangle BDE is equal to, area of triangle ADE, first one, half into AD into EN divided by half into BD into EN. Hope you get the point. Gets cancelled, which is equal to AD by BD. I get one side ratio. Now I have to get the another side ratio. So how am I going to get my another side ratio? That is 2 divided by 3. That is 2 divided by 3, which is equal to 2 is what? Area of triangle ADE divided by area of triangle CED, which is equal to ADE is what? Half into AE into DM divided by half into CE into DM. Gets cancelled, this gets cancelled, which is equal to AE by C. Correct? Now, this I will name this as 5 and this is 6. So, now I got 5 and 6 on either side. This is area of triangle ADE divided by area of triangle CED. And this is area of, I write not in the Roman letter, 1 and 3. Why? Because you have given the numbers 1, 2, 3, not in Roman numbers. So, area of triangle ADE divided by area of triangle BD. So, I got 5 and 6. My aim is, as a math student, my aim is, I have to prove these two sides are equal. That means if I prove that these two sides are equal, automatically these two sides will be equal. Why? Because you know in math, that is, if left hand side of two equations are the same or equal, then right hand side, whatsoever may be the value, they will be equal. Correct? So, this is what my aim is. Now, I am going to prove this is equal to this one. How? That is what the second concept I taught you before the theorem. What is that concept? Now, let me write. That is, triangle CED and triangle BGE lie on the same base. This is the base. You have to see ulta pulta, correct? So, this is not the base, this is the base. But they lie between, I told you, this is parallel to this one. It is given in the statement. And when it is parallel, you can see it is a trapezium. So, this is parallel to this one. So, I can say these two triangles lie on the same base between the same parallel. So, the areas are equal. So, how do I write? Area of triangle CED is equal to area of triangle BD. As simple as that, because since they lie on the same base between the same parallel. Same base and between the same parallel. So, they are parallels. So, the areas are equal. That means numerator already the same and denominator they are equal. That means this is equal to this one. Very directly we can say. So, I can say area of triangle ADE divided by area of triangle CED is equal to AE by CE. Similarly, that is, this is 6 implies, and similarly we can write like this, and then 5 implies area of triangle ADE divided by, instead of BDE, I put CED. Why? Because both are equal. The areas are equal. So, area of triangle CED, that is equal to AD by BD. So, 6 and 5, both are equal. 5 is equal to 6. That implies AE by CE is equal to AD by BD. Hope everyone understood. This is what we have to prove in our theorem, that is the line drawn parallel to one side of a triangle to intersect the other two sides, then other two sides are divided in same ratio. That is the theorem statement. So I have to prove they are in same ratio, and I prove AE by CE is equal to AE by CE is equal to AD by BD. You can write another way also, AD by BD is equal to AE by CE. So hence the proof of the Thales theorem. Hope everyone understood this theorem with this explanation. Before going for understanding this theorem, I told you, those two concepts are very important. Otherwise, you will have a doubt how this altitudes are coming for both the triangles. So that is the concept. Hope everyone understood this one. Now we move on to the converse of Thales theorem. What does it mean by converse? Children, I explained in the previous video that is converse means. So, converse means there will be two statements. Mostly in the theorem, there will be two statements in the theorem always. And one statement implies the other. And the similar way, first statement, that is the theorem says two statements. So one statement, the first statement implies the second statement. Here, if the lines are parallel, then that is the second statement. Then they are divided in the same ratio. That is the second statement. Now what is the converse? If they are divided, the other two sides are divided in the same ratio, then the second statement will imply the first statement. Then these lines are parallel. The line drawn is parallel to the other side. That is what converse is. Everyone knows by this time you are closing the board exam. You are nearing to the board exam. So by this time you must be knowing this, but I just wanted you to recollect that concept. So now the same way we are going for this converse of Thales theorem. So what the Thales theorem says? The Thales theorem, converse of the Thales theorem says, that is, I have a triangle. So triangle ABC. In this triangle, these two sides are divided in the same ratio. That is, I am given AD by BD is equal to AE by EC. I have to prove DE is parallel to BC. DE is parallel to BC. That is what I have to prove. So let me write what is given. Given as in triangle ABC. ABC is a triangle. And second point, AD by BD is equal to AE by C. That is what given. What I have to prove? To prove DE parallel to BC. Correct? So I have to prove DE parallel to BC. Suppose I have drawn the line from the point D. And if that DE, the line I am drawing, is not parallel, what would happen? So that's how I am going to prove this theorem. Why? Because by this, all this 9th standard and 10th standard especially, you will be proving the theorem as we have proved in the Thales theorem, taking the concept, okay, taking the the concept that we have studied, and we apply those concepts and then we prove the theorem. That is one way of proving. It's correct. But the second, other way we prove is by contradiction. So you must have done this in real numbers, the first chapter. Prove that root 2 is irrational, or prove that root 3 is irrational, root 5 is irrational. So let us assume the contradiction. Suppose root 2 is rational. So hope you get to connect that statement. So we are going to prove in this way only, that is using the contradiction. I draw the line. Suppose the line is drawn through this. It is not a parallel. So it is not parallel means what? It will go like this. Correct? Why? Because if suppose that line is, I have to prove it is parallel. Suppose if it is not parallel, so it will go and hit that AC at the point E dash. Correct? So if it is at the point E dash, what will happen? This remains the same. This is already given. My aim is to prove this one. That is, I have to prove it is parallel. Suppose it is not parallel. That is what I am going to take it. Let us assume the contradiction. So, assume the contradiction, which is, I draw the line which is not parallel. That is, a DE dash is not parallel to BC. So, I draw the line such that E dash is the point where that D dash cuts the line AC, and DE dash is not parallel to BC. What will happen if it is? That means AD by BD is equal to AE dash by CE dash now. Why? Why? Because it is already given. That is, I've taken E as a point. If E is the point, I'm not taken E as the point. Suppose it is E dash is the point, but which is not parallel, then this will hold now. So AD by BD is equal to AE dash by CE dash. Correct? 1. But I know that AD by BD is equal to AE by CE. So I apply here AE by CE, which is also equal to AE dash by CE dash. Correct? So both are equal to this one. Now I consider only this ratio, that is AE by CE is equal to AE dash by CE dash. I consider this one. Children, in triangles chapter, you will come across adding 1 on both the side or subtracting 1 on both the side. This is one common concept especially in this chapter in 10th standard, adding 1 so that to prove it. So, to prove what is required. So, what is the question it is given, what is required. So, to prove that, you will come to a point where 1 is added on either side, or this is subtracted from 1. That also can happen. Or from here 1 is subtracted. That also can happen. So, added on both the side means how it will come? That is AE by CE plus 1 is equal to AE dash by CE dash plus 1. Hope everyone understand. I just add 1 on both the side. Now, when you have the integer and fraction is added together, what you will do? You will take the LCM, as simple as that. So, I write, taking the LCM, AE plus CE divided by CE is equal to AE dash plus CE dash divided by CE dash. Correct? Now, AE plus CE is what? AE plus CE is nothing but AC. And CE, which is equal to AE dash plus CE dash is what? Again it is AC. That is by CE dash. So this gets cancelled. So CE is equal to CE dash. Take the reciprocal and you get it. So reciprocal is also one more good point in this chapter. You will be using, I am giving you the hint, what are the concept you will use it to get the proof. So in triangles you must think in different ways which are possible in math. That you will do. You cannot do anything and anywhere, anytime. No. So you should think in this place I can add, subtract, or I can take the reciprocal. So I can take the inverse. That according to the question you must think to how to apply this so that I can get the answer. It must be true also, correct? So CE is equal to CE dash. That means CE is equal to CE dash means E and E dash must coincide. Then only CE will be equal to CE dash. That is CE is equal to CE dash. This length is equal to this length means that both the point must be here only, na? Then only they will be equal, right? So otherwise it will be equal here, or it must lie here. Anywhere it must lie. But I know that is according to this only the ratio holds exactly true. So I take my E dash here. So my observation is this implies E and E dash must coincide. So hope you understand. When they coincide, what happens? It will happen like this only. Nothing will happen. That is, the line DE will be parallel only. So that implies DE is parallel to BC. Hence the proof. So the last step you must write. That is hence the proof. The previous one I skipped it. I thought of it, but I skipped it because we started that converse of the Thales theorem. But you must write hence the proof and then underline. So you score the marks for this. Hope everyone understood this converse of Thales theorem. The converse of Thales theorem says like this: if the two sides of the triangle are divided in the same ratio, then that line dividing the two sides of the triangle, then that line is parallel to the third side. So this is what the converse of the Thales theorem. So you understand this concept. Children, I want everyone, those who are listening the class, please take the notes, and it will be very helpful for you to refer the notes and to put it in your examination to score the higher marks. So this is what are converse of Thales theorem. With this we come to the end of the exercise, the Thales theorem, and we will do the exercise question in the next video. Until then, take care. Bye bye.